an explosion takes place right at the origin. So, to do this question, it looks like an energy question. Yes, it's an energy question. Because we have to analyze the total energies before the explosion and after the explosion. Right? But the thing is, if you want to find the energy, kinetic energy after the explosion, you have to use the conservation of momentum. Right? Because if you want to find the total energy, that means the kinetic energy of the objects, that means you have to know the velocities. To calculate the velocities, you have to use the conservation of momentum. This is a two-dimensional momentum conservation problem, right? Because the objects are going in different directions. So it takes place to analyze two different momentum components, an x and a y. So we have to write down the conservation of momentum separately both in x and y direction. So the question is, you have to answer what is delta k. Okay? That means the difference between the final and the kinetic energy. So, of course, it will be in terms of joules. You see, the answers are given in terms of joules. What is Kf? Kf is equal to 1/2, right? M1 V1 prime squared plus 1/2 M2 V2 prime squared. These are the velocities after the explosion. And what is Ki? Ki is equal to 1/2 the total mass times the initial velocity, right? Vi squared. The initial velocity, because the initial velocity is given as 0.5 meter per second, and the total mass of the object is 1.2 kilograms. So you can easily find the initial kinetic energy. That's not a big deal. 1/2 1.2 times 0.5 squared. So anybody can give me an answer if you have a calculator. But the thing is, what about this final kinetic energy, right? Let's take this object as M1 and this as M2, right? The problem gives the velocity of the M1, V1 prime squared, 1/2. M1 is 0.4 kilograms, and V1 prime is 0.9. Of course, you have to take the square of that. And the kinetic energy of the second object, M2 is 0.8 because the total of the mass is 1.2 times the velocity, V2 prime square. So how can you find V2 prime? There is only one equation to find V2, right? V2 prime, sorry. Since V2 prime with this coordinate system has two components, V2 prime x and V2 prime y. So to find V2 prime, first you have to calculate its components, right? V2 prime x and V2 prime y. How can you find V2 prime x and V2 prime y? By conserving the momentum separately in x directions and the y directions. Initial momentum is in the x direction only, right? So M total V initial is equal to, do we have any contribution of the first object which going down in the y-axis? in the x component of the momentum after the collision. No, there is no x component. So all the x component of the second object's momentum comes from v2 x prime, right? So m2 v2 x prime. Any questions about this equation? I have to conserve the momentum in the x direction. The second object contribute to the momentum in the x direction after the collision. So the x component of its momentum after the explosion is m2 v2 x prime. I know m it is 1.2 and vi is 0.5. And this is equal to m2 is 0.8. It's already given in the question. And v2 cosine x. If you write v2 times v2 prime times cosine theta, you will have two unknowns in your equation. One is v2 prime and the other is theta. Since you don't know theta, if you had already given the value of theta in the problem, then you could do it. But since it's not given, this is the best equation that you can use. So anybody, if have any calculator, you can give me an answer what v2 prime x is. Remember, v2, I need v2 prime square, right? I need v2 prime square to calculate the final kinetic energy. Here, v2 prime square, you see. So what is v2 prime square in terms of its components? It is v2x prime square plus v2y prime square. Right? This is v2 prime is a vector. So the square of the magnitude of a vector is the sum of its component square. Nobody had given me any value about v2 prime x, so I am leaving it to you to calculate, okay? Hesap makinesi olan varsa şunu hesaplasın bir ya. So the second is, how can you find v2 prime y? Arkadaşlar çok durumdasınız. Size söyleyeyim. Yani ya hani desem topluluk içinde konuşmaktan çekinen ya, öyle bir şey yok. Herkes rahatlıkla konuşabiliyor. Bunu eğer yazdıramazsanız bu dersten yani geçseniz bile hiçbir anlamı yok. Bakıyorsunuz ama bilmiyorum. How can I find v2 prime y? 0.75. v2 prime x mi? 0.75.
Diğeri hocam 0.4 çarpı simülatör eşittir 0.8 oradan veriyi
So to find v2 prime y, I have to write down the conservation of momentum in the y direction, right?
Yes.
Give me the value.
0.04 times 0.9.
What is the momentum initially in the y direction? 0. Okay, this is equal to, now you can tell me,
0.4 times
the mass of the first object, 0.4, times its velocity in the y direction, and it is given 0.8, but it is in the minus y direction, so I think I should write a minus sign in here, right? It's going down. Times 0.9 plus 0.8 times v2 y prime. So you can easily find v2 y prime from this, right? 1.8 mi? I trust you. 1.8. So the rest is you will calculate v2 prime. I hope this is correct. Okay, so from this you can easily find v2 prime squared. Once you find v2 prime squared by taking these squared and sum, you can calculate kf. So you already know what ki is. Take the difference, and this will be, the answer will be 0.32 joules. Okay. I will put this in canvas. So I am passing to the next question. Again, you have an object, a mass 4 kilograms, and a second object with mass of 9 kilograms, and they are at rest initially. But the thing is, these objects have a spring in them. Okay? You have two objects. Let me draw a picture. The first one, and we have a compressed spring and these are on a frictionless surface. Okay, so initially you have two objects with mass 4 kilograms and 9 kilograms, and initial velocities are, of course, 0. They are being held, compressing the spring in between them, and you release them. Okay, there is no friction on the surface. You release them, what happens? When you release these objects, which has a spring compressed in between them, the spring will push these objects in opposite directions, right? Because the spring, a compressed spring, always has some force, the spring force. So the question is, what is the velocity of the 9 kilogram mass after these masses are released?
4 times 2 equal to 9 times.
Okay. Again, it's a conservation of momentum problem. So what you do is, it's in one-dimensional momentum problem. Initial momentum is 0 because both objects are at rest. And the final momentum, one object is going east. Let's this direction be east and this direction be west. Okay? Or positive x direction, negative x direction. So we take the direction in the east as positive and the direction in the west as negative. The thing is, this should be 4 kilogram. Okay. Sorry about this. The masses are reversed. This is 9 and this is 4. 4 kilogram mass moves with a velocity of 2 meters per second. So I can write down the momentum of the 4 kilogram mass 4 times 2. It's going in the east direction, and in east is positive x direction. The other is going in the west direction. West is negative x direction, so I put minus sign because its velocity is in the negative x direction. 9 times its velocity, right? So you can easily find the velocity. And when you solve it, V is equal to 8 divided by 9. And this will be 0.88 meter per second going in the west direction. It's a very simple problem. It's conservation of momentum.
We didn't go right minus because we
already give its direction. You see, its direction is in the west direction. So next, you think about, read this question, and it's an interesting question. It's in your textbook. If you had seen the problems at the end of the chapter 10 in your textbook, probably you will have seen this problem. You have a block, and on one side of the block there is a spring attached to a wall, and somebody fires a bullet on the block. The bullet, of course, passes through the the wooden block, with some velocity, and the final velocity of the bullet is not known. But the thing is, you are given that the block has compressed the spring attached to it 5 centimeters toward right. Okay? So the question is, what is the speed of the bullet after it emerges from the block? And the second is, what is the amount of kinetic energy of the bullet which is converted to internal energy in the block after the collision? Any idea on how to solve this problem?
here 1.5 times 9
You have some kind of energy stored in the spring, right?
the initial and the final.
If there is no friction between the block and the surface, and it is so, it is given in the problem. It says that initially, the block is on a frictionless surface. So, from the compression in the spring, we know that when you compress a spring, there will be kind of potential energy stored in the spring. And this potential energy, in fact, is provided by the initial velocity of the block when it is hit by the bullet, right? Because if there were no initial velocity on the block, then there will be no compression on the spring. So I can find the initial velocity of the block before the spring begin compressing, right? And this is an energy problem, the conservation of energy. And I know that the energy stored in the spring is 1/2 kx squared, right? 1/2 k. But the thing is, here the amount of compression is given in terms of another letter d. I can easily write 1/2 k d squared as the energy stored in the spring. And this must be equal to what? Because I know the energy is conserved, there is no friction between the block and the surface. So this must be converted, initial kinetic energy must be converted to this potential energy of the spring. So what is the initial kinetic energy of the block? 1/2 the mass of the block,
5
right, times V squared. That V squared, Vi squared, let me not use I because it means initial, but the thing is, this velocity is the velocity of the block after the bullet hits it. So in fact, It is the velocity after the collision with the bullet and the block. Okay? So let me put this as only V. Okay? But the thing is, I know what M is, 5 kilograms. M is 5. And D is given as 5 centimeters, but you have to convert it to meters. So you should write it down as 0.05 squared. And K is given. The spring constant is 900 Newton per meter. So you can easily solve for V, right? V is, in terms of these values, I have those 1/2 cancel on both sides. I have 900, okay, and divided by 5, which is the mass of the block, and this will be in square root times D. So D is 0.05. Let me write the numerical value, 0.05. So you should calculate in your calculator what the V is. Next, are we done? The question is the speed at which the bullet emerges from the block. Well, we have found the speed of the block after the bullet emerges from it. But the question asked not the speed of the block, but the speed of the bullet. Well, I have calculated the speed of the block. I will use it. I will use this velocity to calculate the speed of the bullet after the bullet emerges from the block. How can I find it? The speed of the block. Let's call it V final, and V final is given in here. Anyway. What kind of principle I should use to find this V final? An energy conservation again, or momentum conservation, of course. And I know that before the bullet hits the block, whatever the momentum is, and this will be equal to the velocity of the bullet, right? After it emerges from the block times its mass and the velocity of the block that I have calculated or is waiting to be calculated times the mass of the bullet. Let's write it down. Initial momentum is, since initially only moving object is the bullet, right? Vi, here Vi is given, and am I given the mass? The mass also is given. The mass of the bullet here is given as 5 grams. So what is the initial momentum then? 0. Or let's write it as in scientific notation, 5 times 10 to minus 3 in kilograms, times the initial velocity of the bullet, which is 400 meters per second. It is given in the problem. 400 meters per second. And this initial momentum must be equal to the final momentum. And the final momentum is, again, 5 times 10 to minus 3 V final. It is the final momentum of the bullet after it emerges from the block, plus the mass of the block times
Mass of the block
this V, right?
1 kilo.
Okay. The mass of the block is 1 kilogram, sorry. It's 1 times this V, right?
Yes.
What is it? Hesaplayan var mı? Derse biraz katılın ya.
Hocam biz okulda yani o 25 almıştık. O bloğun 1 kilogram mı? Yukarı.
5 gram şu mu?
0.60
Hayır, en yukarı.
Hangisi?
Şu büyük
Ha o 5 değil tamam.
O 1.
Bu 1.
O zaman orada şey fark. Ne olur? 30 mu?
Bu da 1 olacak.
30 çıkıyor.
30. 1
çarpı 0.
30.
0.05 de var.
şununla çarpmanız lazım. 30 çarpı 0,05 ne yapıyor? So 1 times 1.5 meter per second. So from this, what is V final then? It is 5 times 4, 20, and 2 zeros makes it minus 20. 2. This is 2, right? This is 2. Is it 100? V final. V final is 100 meter per second. Okay. Well, this is logical because initially the bullet had 400 meter per second velocity. After it passes through the block, its velocity of course will be reduced, and it is reduced by 1/4. The thing is, we will find the amount of kinetic energy of the bullet that is converted into internal energy of the block. So for this, you have to take the difference between energies. What kind of energies then?
Take the difference between
Energies. The energy of initial energy of the bullet, right? Because initially the block is not moving, right? The initial kinetic energy of the block minus the final kinetic energy of the block, right? That's what the question asks. What is the amount of kinetic energy of the bullet which passes to the block, right? So initial kinetic energy of the block is 1/2 small m v initial squared, which is 400 square, minus 1/2. Again, the mass of the block, which is 5 times 10 to the minus 3 kilogram, 100 square. When you calculate this, you will find the amount of energy of the bullet that is passed to the block, right? So you can do it at home. It's not a big deal. Evet, şu 1 çarpı 1,5. 1,5 şuradan geldi.
Oradan
30 çarpı 0,05. Ha. Next. I don't know why this question had again only very few correct answer. The question is, a 3 kilogram object is traveling with 20 meters per second to the west, and it collides with 5 kilogram mass. Again, it's going in the same direction with 12 meters per second. And it says that collision is perfectly elastic. What is the velocity of 3 kilogram object after the collision? Bunu karşısına quizde bu çıkan var mı bu soru? 9 kişiye çıkmış galiba.
Bu soru bana da çıktı hocam.
Bana çıktı diye.
Yaptın mı?
Ben bunu soracaktım aslında hocam size. Gerçekten vallahi aklımda.
Evet. So all initial velocities are given, and the velocity of the final velocity of one object is given, right? And you will find that's v2 prime. Let's write all the given values. M1 is 3, M2 is 5, V1, the initial velocity of the first object, is 20, and V2 is 12, and V2, well, V2 prime is given. Okay, no any velocities after the collision is given. V1 prime and V2 prime are not known, so you'll find the velocities after the collision. Which equation should you use? Kaç çıkıyor? 10 çıkıyor. So which equation should we use? Remember, from the conservation of momentum that I am given here. This is the type of elastic collision, right? And remember, you had this equation V1 for V1 prime and V2 prime for elastic collisions. You can use these equations right here. Right, everything is given. Let's calculate V1 prime first. Well, the problem says the collision is elastic. What is the velocity? 3 kilogram object. So the 3 kilogram object is the first object, so I will have to calculate V1 prime. And you just use this equation, that's it. M1 is 3 minus M2 is 5, and it will be divided by the total mass, 8, times V1 is 20, and plus 2M2, which is 10, divided by 8, and V2 is 12, right? So you say it is 10, okay. When you solve it, you are expected to find is 10 meters per second. It's a single line. Okay, let's look at another. So next question. I think you had but you should be careful because the directions of the velocities are different. If you take this direction as positive, then the initial momentum is 9 times 2.1 minus, because 3 kilogram is moving in the negative x direction, 0.6, or let's the mass, write down the mass first, 3 times 0.6. And you will calculate what this is, and also you will calculate 9 times 1.5 plus, this time plus, 3 times 1.5. You will see that these are not equal to each other. So the momentum is not conserved. That's it. You cannot say anything about it, the type of the collision, because the momentum is not conserved. We can say the collision is elastic or inelastic only if the momentum is conserved. Okay? We concern the type of the collision only when the momentum is conserved. If the momentum is not conserved, you cannot say anything about the type of the collision. Okay, I think this is understood.